I thought you said let us be gay. That's kind of what that I mean, yeah. Let us. You gotta change it up.
Okay.
Today,
we are going to take a look at some rules of logarithms. These rules are actually very closely related to our rules of exponents. The product rule, okay, if I'm multiplying two things inside of a log, I can split this up a certain way. Okay? If I've got log base A of m times n, I can split this up into two separate logs by adding the logs together. So I can say log base A of m plus log base A of n. This is really, really closely related to this rule. If I've got a to the m times a to the n power, well, I can just add the exponents together. Right? I can write this as a to the m plus n. That's where this rule comes from. Okay? Since logs are equal to exponents, okay, we have similar rules between our exponential functions and our logarithmic functions. Okay? So an example of something like this could be if I've got log base 4 of 3x, okay, and I want to split this up. Well, I could write this as log base 4 of 3 plus log base 4 of x. Okay, I can split that up into two different logs. I can do a similar thing if I'm dividing two different things inside of a log. Okay? I can split this up into two separate logs by subtracting the logs. So I can say this is log base A of m minus log base A of n. And again, this is really closely related to this rule for exponentials, right? If I have a to the m over a to the n, that's the same as a to the m minus n. Okay, that's where this rule comes from. So an example of that could be if I've got log base 4 of 3 over x. I could rewrite this as log base 4 of 3 minus log base 4 of x. Our final rule is the power rule. This one just says if I have an exponent on the inside, I can bring this out front as a coefficient. Okay, so log base A of m to the r power, I can just bring that r out front and say this is r times log base A of m. Okay, and this rule comes from our power to a power. Okay, so if I have a to the r to the m power, that's just the same as I'm multiplying the powers together. Okay. So an example could be if I've got log base 4 of x cubed, I can just bring that exponent out front and write this as 3 times the log base 4 of x. Less. Okay. Now the last two aren't necessarily rules, they're just kind of special cases. So number 4, if I've got log base A of m equals log base A of n. That's true. What do we know what this IFF means? Can you see that?
You mistyped it.
No, that's on purpose. If you ever see something like this, IFF, this means if and only if. Okay, IFF is just short for if and only if. Okay, and it's a math idea, meaning we have to be true going this way in the statement. So we're saying if this is true, then this is true, and the converse has to work as well. We have to be able to go backwards. So saying if this is true, then this is true. Okay, that's what if and only if means. Okay, it means we have to be able to go both ways in our statement. If and only if and only if. So for this statement, okay, if we have two logs that are equal to each other with the same base, okay, that's important. In this statement, notice the bases are the same. Then what's on the inside of the logs has to be the same. So we can say, in this case, m would have to equal n. Okay, so if I have two logs that are equal to each other with the same base, then whatever's on the inside of those logs has to be equal. And the last one is just a special case of the quotient rule here. So if I've got 1 over something inside of my log, if I use my quotient rule, this would become log base A of 1 minus log base A of m, right? But what's log base A of 1? A to what power equals 1? 0, right? Anything to the 0 power would equal 1. So this, log base A of 1 is equal to 0. So this is just equal to negative log base A of n. Okay, just a special case of the quotient rule. Okay, if we have 1 over something inside of the log, that part would go away because log base A of 1 is just equal to 0. Okay. Questions so far on these rules? But not yet. That's what I'm asking. So let's jump into some examples and use these rules here. So first, we want to expand these logs as far as possible using these rules. Okay, so first I've got natural log of x minus 2 over x plus 3. Okay, well I've got division here. So how can I split this up into two different logs if I'm dividing two things inside of that log? Subtract, right? So I could rewrite this first as natural log of the whole numerator, right? X minus 2 minus natural log of the entire denominator, right? X plus 3. Can I expand each of those any further? Hope not.
Oh, wait. Yeah, you just get rid of the log symbol. Because aren't they both natural logs?
Oh, I see what you're thinking. You're thinking like number 4 up above.
Yeah.
That's only true when we have an equation. So if I'm saying these two things are equal to each other, then I can say what's on the inside is equal. But this is just an expression. There's no equal sign, so we can't just get rid of the logs. Good thought, though. So this is as far as I can expand this log, right? Our rules up above were, if we're multiplying or dividing on the inside of the log. Here, we're adding and subtracting on the inside of the log, so I cannot split those up any further. That would be my final answer. That would be as far as I can expand that out. Okay? So let's take a look at B. We've got log base A of the cubed root of x times y to the 5th. Okay? Whenever we're doing problems like this, the first thing that we want to deal with is the multiplication and division. The second thing we'll deal with is the powers. So it's kind of reverse PEMDAS. to look at the multiplication and division first when I'm splitting it up, and then look at the exponent second. So here, I'm multiplying the cube root of x times y to the fifth. Yeah, so first I'll say log base a of the cube root of x plus log base a of y to the fifth.
Do you do anything to the log if there's a square root or like a cube root?
Yeah, so what the next step would be to deal with the powers, right? And we know whenever we have an exponent, I can bring that out front as a coefficient. So how does that apply when I have a root? The cubed root of x is the same as the x to the 1/3 power. Okay? So before we bring our exponents out front, I'm just going to rewrite the cubed root of x as x to the 1/3 power. Okay, so when we're doing these, we want to think about whenever we see a root, we want to turn that into a fractional exponent. So then this would be still log base a of y to the fifth. So now I can pull those exponents out front as coefficients. Okay, I can bring this 1/3 out. So this will be 1/3 times log base a of x. And then I can bring this 5 out front. Say this will be 5 times log base a of y. Okay, so we're just using these three rules to expand as far as possible. Okay, so whenever we see multiplication or division, I'm splitting it up into two separate logs using addition or subtraction. And then whenever we see an exponent, we're bringing that out front as a coefficient.
Is the denominator in like a fractional power always whatever the root is, like it's a cube root or a square root?
Yes, the denominator in the fractional power is always the root. And then the numerator would be, like if this were the cube root of x squared, that 2 would just be the numerator.
I see.
Okay. Any other questions on something like this? Okay, let's take a few minutes then, and you guys try C and D. Yeah. So the square root is the same as what the fractionalized one. Square root is the same as what we have.
Listen to that. Oh. Yeah. It was just one way it was wrote. I didn't realize
The square root is the same as a 1/2.
it. So it's just minus. So yeah. Shut up.
Would I break up the 3 and the x and the 5 and the root?
Mm-hmm.
Oh my god.
Dude, you know that. He's starting to act that way for our class too.
Yeah.
No, he's like that to us. I literally ask him questions. He just ignores Yeah, he's sitting there playing the football game when we were getting talked to him. I don't know how we I know! Drink 2 of them before 8:30 last Friday. Is it
I think it's just oh, I know. Just 2 to 4.
Oh god, that's not what I got.
You still have one more step. Right? You can split these up
Oh.
into the natural log of 3 and the natural
Yeah,
log of
I get where I was wrong. Who's that?
So for C, okay, I think a lot of people got C correct. Okay, the first step would be to write this as 2 separate logs using subtraction. So log base A of x minus log base A of x plus 7 squared. And then on the second log, I can bring that exponent out front as a coefficient. Okay. On D, there's a little bit more going on here. Right? So the first thing we wanted to do was split this up into 2 logs, because I'm dividing on the inside. So log, or natural log of 3x squared minus natural log of 5 times the square root of y. And I went ahead and changed the square root of y into y to the 1/2 power. Okay, well now, I've got multiplication on the inside of each of these logs. I can split that up into 2 separate logs. And write this as natural log of 3 plus natural log of x squared. And then over here, natural log of 5 plus the natural log of y to the 1/2. Now, notice, and you need to be careful of this when you're writing these, I put an extra set of parentheses around this second set to show I'm subtracting both of these. Okay, that negative sign that was here would need to apply to both of these logs when I split that apart. Right? Everything past this negative sign here, okay, that negative sign would need to essentially be distributed to. So I put parentheses around it. You could just show that both of these are subtraction signs instead. That's up to you. Okay. And then the final step, we had exponents here and here, so I can bring those out front as coefficients. Okay. What's that? Does it make sense, though? Any questions? Alright, so then the next part is just going backwards. So given an expanded log, we want to condense this and write it as a single log.
You teach it back.
So here, okay, I've got log base 2 of x plus log base 2 of 5. There's only one thing going on here, right? I don't have any coefficients. All I'm doing is adding these 2 logs together. So if I'm adding 2 logs, how can I combine them into a single log? Right, just multiply what's on the inside. So this would just be log base 2 of x times 5, or of 5x. Okay, now the rest of our examples here do have coefficients. Whenever I'm condensing, we need to deal with the coefficients first. Okay, coefficients need to become exponents first. So I've got a coefficient on my first log. So 2 log of x is just going to become log of x squared, right, and then minus log of 3y. So now if I'm subtracting, I can combine them into a single log by dividing what's on the inside. That was going to be my next question, yes. So if we don't see a base, the base is 10, as Sam just informed us. Okay? Why are you going to get it wrong? Okay, so first thing we need to deal with is our coefficients becoming exponents. So this 3 will come up here, this 1/2 will come up as an exponent here. Right? So my first step, I can write this as log base 3 of x cubed plus log base 3 of 4x plus 3 to the 1/2 power. Now if I'm adding, I can combine these into a single log by multiplying what's on the inside. So log base 3 of x cubed times 4x plus 3 to the 1/2 power. Okay, now we could rewrite this instead as the square root of 4x plus 3, but I'm fine with you just leaving it as the 1/2 power. Okay. You okay with that one? How about the last one here? I think this one's actually not too bad.
You also have a degree.
Yes, I have a degree in logarithms.
Yes, a degree in math stuff.
So, we actually have a couple of options for this last one, but I think there's one way that will make this easier. I think it would probably be easiest to just distribute this 1/3 through the parentheses first. And make this 1/3 natural log of x minus 2y plus 3/3, which would just be 1. Natural log of z. Okay, so don't forget when you're doing something like this that you can still distribute through parentheses. And I think that makes this problem a little bit easier. So now we can bring our exponents up. So this would be natural log of x to the 1/3 minus natural log of y 2/3 plus natural log of z. Now I can combine these using division and multiplication. So first, if I'm dividing here, this first part will be natural log of x to the 1/3 over y to the 2/3, then times z. So should the z go in the numerator or denominator here? There aren't parentheses, right? So I'm not multiplying by 1 over z. There aren't parentheses here showing that I should distribute a negative sign. So my z should actually go in the numerator. Okay. If I'm adding, if there's a plus sign there, I'm just multiplying by what's on the inside. So I'm multiplying what I had by z. That means the z should go in the numerator.
And that's how it'll always be if it's not distributed.
Yeah.
So if there's like 2 negative signs, that's just multiplying the 2 values in the denominator.
Yeah, exactly. If this were a negative sign here instead, the z would go in the denominator. Okay. Questions on those? All right, so then, oops. 2 more things real quick here. Okay, so on example 3, we want to use these same ideas, but now we're given values. So I'm going to need to split these logs up and then use what I'm given to get a final answer. So for this first one, I've got log base 4 of y over x. Well, I can split that up into two separate logs and make a subtraction, right? So I can write this as log base 4 of y minus log base 4 of x. Well, now they give me some information, right? They tell me log base 4 of y is equal to 5. So I can just replace this with 5. And then they tell me log base 4 of x is equal to 3. So I can just replace this with 3. So 5 minus 3 gets me that this is equal to 2. Okay, so they're just telling me, these two things are equal to a certain value. So I can, once I get those things by themselves, I can replace that value that they give me. So first we need to expand the log so that I can see each of those pieces. Okay? See if you can do the same thing for b real quick here. You get 11? Okay. Questions on that? All right, then I think the last thing we'll have time for is logs on a calculator. So on your calculator, okay, we no longer need to use a change of base formula because there's a button on your calculator that you can put in any base for a log. So if you're in your calculator and you press the math button and scroll, it's actually quicker if you scroll up, okay, because it's at the bottom of the list. Okay, and you see log base. Okay. Click on log base. So hit enter, and it'll give you something like this, where you can put in the base and you can put in whatever number you want to evaluate. All right. So for this one, what are we evaluating? Log base 4 of 11. So I'll put in log base 4 of 11. And enter. Yeah, because it's A. Yeah. Crazy. Okay. Questions on that?
How about we done?
The homework is on the bottom of the paper. Now, these last two, 99 and 101, are similar to example 5, which we didn't get to, but they're also very similar to the problems that we've been doing. Okay, you're just going to use A equals PE to the RT. Okay, so see if you can figure out which pieces go where. Okay, so yeah, I still want you to take a look at them and try them. Okay, they're very similar to the PERT problems we did in the last section.